This is part 2 of section 3.1. We want to use transformations to sketch the graph of f of x is equal to 2 to the x minus 1 plus 3. Okay, so remembering what we did in chapter 1, I'm going to start with my basic graph of f of x is equal to 2 to the x. That's what I'm going to start with. You can think of that as your library function, the one you want to shift around. And then it's all a matter, I have a horizontal shift and a vertical shift in here. Remember, vertical shifts are outside of your function and horizontal shifts are inside your function. So I'm going to have a horizontal shift of 1, and horizontal shifts seem backwards. So since this is minus 1, I'm going to go right 1. Okay. And since this is plus 3, I'm going to go up 3. Okay. One of the first things you want to do is that will help is to take your asymptote and shift it. Okay. Well, it doesn't make any sense to shift a horizontal asymptote left and right because it's not going to move because a line is infinite. But I can move it up 3. So I'm going to go ahead and draw in my little dotted asymptote here. Okay. So I know my graph is not going to go below that unless I have a reflection. Okay. And now I'm just going to take these values. I'm not going to worry so much about these because I know that my graph is just going to slide down and get closer and closer to my asymptote here. But if I take 0, 1, which was right here, I'm going to move it right 1 and then up 3. So that's here. Okay. And then I had 1, 2. If I move it right 1 and up 3. Okay. I had 2, 4. Move that right 1 and up 3. And then I had 3, 8. Right 1 up 3 is about right there. And then over here, that was 1/2, so it would be right here and then closer and closer. And so this graph will look more or less like this. Okay. Everything that you've done before is just a new graph to start off with. Okay, now another type of problem. Let's find the exponential function of the form f of x is equal to c times a to the x, whose graph contains the points -2, 16, and 3, 1/2. So I'm going to need to find both c and a. So I'm just going to plug in, let's start with f of -2. That would be CA to the -2, and I know that must equal 16. I can solve this for C and then use that C value in here with this one and hope I can get an answer. Well, this is the same thing as C over A squared is equal to 16. Multiply both sides by a squared, and you find that c must equal 16a squared. Okay, so now I can use this in right here to basically improve what I know a little bit. Okay. Now I'm going to use this. If I plug in 3, I should get 1/2. So f of 3 is equal to 16a squared times a cubed, which is 16a to the 5th, and that has to equal 1/2. If you divide both sides by 16, you get a to the 5th is equal to 1 over 32. Okay, so take the 5th root of both sides. It's an odd root, so I don't have to worry about a plus or minus. And I get that a must equal 1/2. Okay, so I have a good number value for a. So I can replace that a with 1/2. I still need a number value for this c. So now take this and plug it in here. C is equal to 16 times 1/2 squared. So this is 16 times 1/4, which is 4. The equation we're looking for, or the function value all simplified, is f of x is equal to 4 times 1/2 to the x. Okay, now we're going to be talking about various forms of interest. We're first going to talk about simple interest, okay? And the formula for this is the simple interest I on a principal P, and principal is how much money you have invested, at a rate R, which is going to be expressed as a decimal, per year for T years. For all of your interest formulas we're going to learn, T is in years. You may have to do some conversions. Then the formula is I equals PRT. Simple interest problems are an example of linear growth. So they're just going to go up like that, as opposed to an exponential that starts off slow and then shoots way up. Okay? So let's look at an example problem. Juanita has deposited $10,000 in a bank at simple interest rate of 7.5% for 2 years. How much interest will she receive, and how much money will be in her account at the end of 2 years? Okay, so the formula we need is I equals PRT. So the interest is equal to the principal, which is 10,000, times the rate written as a decimal, so 0.075, times time in years, and it's 2 years. Okay, now if you do all of this multiplication, you get 1,500. So the amount of interest earned is $1,500. So how much is in her account at the end of 2 years? Well, you still have the $10,000 you started off with, and you add the amount of interest to get $11,500. And that is your answer. Okay. Now, this is simple interest, and we're going to be also learning about compound interest. And the difference is that with compound interest, periodically they take all the interest that you've earned and roll it into the principal so that you end up earning interest on your interest. Okay? And that means that the amount of money you get grows much more rapidly than just simple interest. And it ends up being exponential growth. All other things being equal, the more times an investment is compounded in a year, the more money you end up making. Okay? So if you're talking about investing the same principal at the same rate for the same number of years, if it's compounded monthly, you're going to earn more money than if it's compounded weekly. Oh, no, monthly more than, say, annually or semi-annually, something like that. Okay? So first, we're going to talk about just annually compounding interest, as opposed to simple interest. And this is only compounded once a year, and we're going to see that you do end up making more.